Good morning and welcome. This is Professor Thayer here with you today to talk about working with TensorFlow. So today what we're going to do is we're going to learn how to make some simple regressor models using a data set. So we'll take you from starting with downloading the data set, cleaning the data, and talk about that. Basically, I'm going to follow the procedure outlined in this book here, which I bought on Amazon. It's Daniel Anis's book about machine learning using Python. So you may also wish to work with that, which really does give a lot of great background information and so on that you may find to be helpful. So let me go ahead and just share my screen. So I am going to be working in the Linux environment, and you can see that I am working with Anaconda Spider is the interface that I'm using to deal with this. So what I have done here is I have set up my code in this pane over here, and then I have simply just run the data, which I can actually, all right, so just go ahead and do this again for you so that you can see what this is going to look like. All right, so I'll take you through all of these steps, but I think it will just be useful to have our output frame over here, and our plots are going to be up here, and then we have our code over here on the left-hand side of the screen. So let's just get an overview of what we are going to work on. Basically, there will be 4 parts of what we'll be looking at today. First, we'll be working with the data frame itself. So we have some data set. We're actually going to be working with the housing data set, which we will explore using the tools in pandas. So that will be our first part, is learning about our data and perhaps cleaning that up a bit to remove any outliers and so on that may be problematic. In the second part, what we're going to do is we're going to remove the outliers from our data set. We'll be using the z-score method to do this. And in the third part, what we're going to do is visualize the data using Seaborne and Matplotlib. You can actually see the preview of our plots right up here. So we'll be taking a look at that and learning how to do the plotting. And finally, we will do the regression. We'll actually take a look at 2 different regression models. We'll look at a linear regression model and a decision tree regressor. So then let's dive into the code, into our code, and get a little bit more detail on what is going on here. So first of all, we do need to do some imports to get started. So we're going to import the packages that we're going to be working with today. So we're going to use pandas, numpy, scipy, matplotlib, and Seaborne as our major packages for today. We do have a couple other imports, as you might see peeking down here as we move through this, but these are the major ones. If you haven't installed these already, it will be important that you are going to install those. So working in the Anaconda environment, this is actually really easy to do. What you can do is go back to your navigator page. So this is my Anaconda Navigator, which I can access here. Let me just show you. You can access this. So this is Linux. So we just do Anaconda Navigator typed into just the system terminal on the Linux machine, and this launches that. If you're working in another Windows system or so on, you can launch this by clicking on the appropriate icon. Here is our Anaconda Navigator, and we have the spider, which is what I am working with. But it's actually pretty easy to do the installation, no matter which interface you're working in, whether you're with operating system, whether you're in Windows or Unix or Mac and so on. And this is your Qt console, and you can launch this and you can do your installations from this. What you don't want to do is do your installations from your systems console, because you need to be inside the Anaconda framework. So you can do that by launching this and doing your pip install or whatever your preferred method for getting the information from the repositories. You can also do Conda to get a number of the packages, and some of them are even available in both. But you do need to have those installed before you can do this. So you'll need pandas, numpy, scipy, matplotlib, Seaborne. Also, I'm using TensorFlow And so TensorFlow has a number of dependencies, including the scikit-learn, which is one of the ones we will see later in today's script. So moving on to part one, first thing we're going to do is import the data set. So this is a particular data set that I've downloaded from the web. You can download your own data set. Basically what you need to do is you need to point the pandas to read the CSV file, and you need to provide the path to wherever your data is. Mine happens to be in my downloads folder for convenience. And so we'll select DF just to remember this is our data frame, and PD is standing for pandas. Notice that we have these single letters up here or these abbreviations, which are going to just allow us to access those namespaces a little bit easier without typing out the whole thing. CSV is comma separated variable spreadsheet. Basically, you can save an Excel spreadsheet in the CSV format, and you can open your CSV files using Microsoft Excel if you would like. And so the pandas will in fact read these. So what we're going to do now is just get a little bit of information. So I purposely haven't told you about what's in the data set, because imagine that you received some data set and you want to explore this using pandas and working in this environment. So you can in fact do that. So what we have here then is the head command. So this DF means that we're going to use the DF, the data frame object, and then the method that's associated with that is head. So this is from a class of objects from the that resulted from the reading of the CSV file. So what this is going to do is it's going to read the first 10 lines of our data frame, and we look over here in the output and we see that we are getting this output right here. We see that we have the information about the headers, right? This is the column labels, and then we have our first 10 pieces of information. So it appears that in fact the index is beginning at 0 in the Pythonic way. So in fact, starting from 1, we would get 11 lines. But anyways, it just gives you a sense of what is here. We can see that we are getting some information about the houses, the year that it was built, the square footage of the house, the type of the house, being semi or detached. Here's a piece of information that's missing, NaN. We'll deal with that soon, townhouse and so on. Also, we have the information about the garage, how many cars can go in the garage, whether it has a fireplace, whether it has a pool, and the sale price. The sale price is the item that we will be aiming to predict. So one of the things we might want to know about is how big is it? So we couldn't, in fact, print the whole thing, but it would likely scroll off the screen. It would be difficult to read. So we can use some of these things to help us see what is in our data frame. So we can do shape of data set. Here we're going to do df.shape, and we see that we have printed our string right here just to mark our place, shape of data set being printed here. And 1000,7 tells us that we have 1000 entries by 7 headings. 1, 2, 3, 4, 5, 6, 7. Yes, we can see there are 7 headings displaying here. Next, we can get some additional information about the data. So we're also asking for the types in the data. So this is going to tell us about the Python types, or what Python is interpreted as the types of the data. So we see that we have some integers and some floats. So the integers are the ones that do not have the decimal values, and the floats are going to describe the numeric data that has the decimal components. So the sale price and the number of cars in the garage are reported in this way. And also we have this other interesting category, the house type and whether there's a fireplace and pool, that are basically strings. And so we see that these have been interpreted as type object. Now we're going to need to deal with those in a moment, because when we go to train our models, it cannot train on words. It needs to train on numeric data. So we'll need to convert that to numeric data, which we'll be doing shortly. So the next thing we can do is we can also use the describe, df.describe. So let's see, here is our describe the data. And so we can see that what we have gotten out is some information about the various columns in the data set. So of course, like I said, we could scroll the data set in its entirety, but that would be cumbersome, and we can get the summary type data, which may be more useful, especially as the spreadsheets get very, very large. So here we have the number of counts, the mean, standard deviation, min, and then we're going to have some information about the cutoffs for the 25th, 50th, and 75th percentile, and the maximum data point. And so this is very useful for getting a sense of the range over which your data is going to work. Next thing we might want to know is how many null values that we have in each column, because we may wish to remove those, and also just get a sense of, is this a poor data set or is it fine? And so in order to do this, we are going to use this little formula here. We're going to get our total count by using the df.isNull, which is going to search to see if there is some problem in the data set, right? There's NaN or whatever being supplied as the input. We see there's one right there. And so we can then use this formula in order to figure out how many there are. So using the dot notation then to access well, to get the answer to one thing and then pass that on to the next method. Here we see that we are looking to see if something is null, and then we are going to sum the number of times that returns true, and then we can sort this according to the values. Here we'll just print out our total count, and so we can see that actually we have our summary right here. The next thing we're going to do is, now that we know that there are not too many null values, is we may be able to drop the ones that have some problem in the data. So we're going to use the drop idea with this. So in pandas, when you have drop, what that's going to do is it's going to basically apply a mask to your data set, and it can remove or exclude items that meet some particular criteria. So df.drop NA will drop the data that has the not applicable, that it's not applicable, right? There isn't a value there. And so that's what we want to do to remove the null values from the data set. Drop NA is that particular mask that will be applied. The access is going to describe whether we wish to remove the rows or the columns that are associated with this. So basically, if we have something that has missing information, what we want to do is we want to drop the entire entry in the data set to remove that data point from the data. So we want to remove the column. So that would be the axis being equal to 0. The axis equaling 1 is going to select your Y. So that would be throwing out a whole column or doing something different with a whole column, which we're going to do when we start doing our training, because we will want to select the data set except for the items that we're trying to predict, and then have the number that we're trying to predict. So that's what these are for. And then we can print the shape. So we see that we get 980,7, which means that we have lost 20 data points out of 1,000. And quickly eyeballing this looks about right. So we could see we've got 10 items that have house type that are having null values, and 6 and 5 is 11, 13, 14. All right, so it hasn't removed every single one of these, so this doesn't exactly add up, but this is how the algorithm is going to work. We're going to drop the data that has problematic points in it. And so also then we still remain our 7 columns. All right, so the next thing we're going to do is we need to deal with these categorical strings, these things that have words in them instead of numeric data. So the columns that have this problem have the heading called house type, fireplaces, and pools, which we have been able to tell from doing our description of the database. So we're going to just set up a Python list with the titles of the columns that we need to deal with. So now we're going to use the label encoder in order to do this. So here we're going to cycle over our categorical columns and basically do the replacement in each one. So this is how we would do that. So df of the categorical column is going to select that particular column. This is just an indexing operator. And then we're going to do label encoder, and we're going to ask this to transform that particular categorical column. So what it will do is it's going to automatically convert those into numeric values. So all the yeses and all the nos will respectively get their own numeric value. The same will be true in the house type data. It will convert those for us. After we're done that transformation, we may wish to look at the data again. So what we're going to do is print out the information about the conversion between them, and we will again do a head of our data and take a look. So let's come over here to see what's happened. So we're going to check to see if the conversion has in fact changed this. And so when we look at this data, what we see, okay, so this is the ellipsis being shown here because it's not expanding out all the way to show every single column. But we notice, for example, that the fireplaces and the pools now, instead of having those yes or no, now have numeric values. And the same will be true for our house type, which we had a couple of different categories, and so we see it's been converted to zeros, ones, and twos, and numeric data. So that's great, and we can also confirm the size of the data set and the types of the items, and we see that we no longer have those objects in here. They have been converted to type int, as we have seen up here. So that's great. Our data is now getting processed to be ready to use for the training. So the next thing we're going to do is we're going to remove the null values from the data set and recheck its shape. So we can do, again, this df.drop NA. Oops, sorry, lost my place. We're down here in the encoder, so we're going to do the encoding and we take a look at that. All right, so the next thing we're ready to do is the z-score. So we'll move on to part 2. This is going to remove the outliers from the data. So in part 1, we basically dealt with the data that may have some obvious problems in that the data is incomplete. But you could also have bad data in the sense that it is statistically an outlier, and we may wish to remove that. So we can use the z-score methodology in order to remove data which does not meet some statistical requirements. So what we can do then is we can do this here. So df equals data frame of the z-score being less than 3, and then we're going to apply this to all. And again, we're going to do column-wise selection by the axis equals 1, which says we should be comparing by columns to determine whether some value is an outlier. So then we can see what will happen. We can print the data for the data frame after we have done the z-score culling. So that is what we are seeing down here. Again, we have 987, which is great because that matches the size we had seen after we had removed the null values. So that's terrific. Next, what we're going to do then is move on to part 3, visualize the data with Seaborne and Matplotlib. So let's just go down here. So when you run the plotting, you have some plotting things. If you're using this particular interface, your plots are going to show up in this pane up in the upper right hand side. Now by default you may have a different tab open, so notice that these are little tabs here that are going to show you various pieces of information. This, for example, is displaying the file system, and we can see our script right here, but this is useful just to see what you might want to open, which you can do with file open. The variable explorer defines all the variables that are in your script and tells their current value. We get the type, the size, and so on. We also have the help functionality here. And so you need to pick the correct tab. You need to just click on the plots in order to be able to see your plots. And the plots are going to be scrollable over in this pane here. So for example, I could click on this one or this one to view those plots. So let us see how we can make the plots and understand what might be going on with these. So I'm just going to click on the first one so that we'll be set up to talk about that. So let's see what we have over here. Here we have the sale price distribution. Let's say we wanted to find out what is the distribution of the sale prices that we're trying to predict. And so how could we get that plot? So we're going to print out the overall sale price distribution. And now notice that we are switching over to using Seaborne, which we had abbreviated with SNS. So we're going to use the distribution plot functionality, and we're going to do DF of the sale price. So this means we are selecting the sale price column in our data frame, and we are going to plot the distribution of it. So in fact, it's that simple in order to get this distribution plot. So much easier than manually binning these things up. So here we see is the plot of the distribution of the sale price for houses in California. So there is a large number of houses that are right around the 500,000 mark. That's about $500,000. And then there's also another amount of these which are following it around the 2 million mark right out here. So we're seeing, in fact, the actual distribution being traced out by this, and we have some coloration behind here that is giving us some information about the actual nature of the distribution. So that's useful for us to know about our housing data, because now we have a sense of what the overall distribution of that looks like. Next thing we might want to do is make a box plot. So let me just go ahead and click on the box plot here. So the box plot is going to tell you information about how the actual distribution is occurring. So here we have our output. So let's see how we got this. So data 1 is equal to pandas, and it's going to concatenate together the sale price with the house type. So this is basically a plot that's going to take a look to see how the sale price, which we have on the y-axis, is being predicted by the type of the house. So here we are basically selecting the x and y axes to use. Now this axis equals 1 means that we are selecting by a column, and so that is useful to know, because basically it means we're going to pull this column-wise, and these are the headings of the columns. So now the next thing we're going to do is we are going to make the subplot. So this is actually setting up our figure. So here we have f comma ax is going to be equal to the Matplotlib subplots, and we are setting up the size of the figure here. So you can just change these numbers to affect how the plot is going to render. 14 and 8 looks like it's working really well for this. Next, we can also, in fact, actually do the box plot part. So this is also basically fitting up the data into your plots. You need the house type and the sales price, and we're specifying the X and Y. And the next thing we're going to do is configure the maximum and minimum. So here we have the axis running from 300,000 to over 2 million. And we see that that's right here. Notice the lower one is omitted with actually having a label, but we do have those here. And from this, then we can we can take a look at the graph, which we see over here, and we can see that the house type of 0 is having a sale price of 200,000. So the house type category 0, I do believe, is the attached version of the houses, whereas the detached houses are worth a lot more money. So the next thing we might want to do is we might want to make a heat map to do the correlation. So let me just click on this to bring this one up. So now we might want to ask the question about how data sets are going to correlate with each other, the various data points. So here we're going to do the correlation matrix equals df.core. So this does your correlation calculation. F, AX, again, is similar to this notation up here. You're going to do plot.subplot, and now your figure size is being specified. And then we can, in fact, do this calculation. This here is just making a selection of which color scheme you wish to use. Notice we're running from yellow to blue here, and this is a particular configuration to pick out the color scheme that's desired. These are pre-configured, just probably a way you can make your own, but this is the one that I picked. So this is yellow, green, blue, YLGNBU, in order to display that. And this is the plot that we get. So we can take a look at this then to see which ones are more highly correlated. Of course, the self-correlation is coming out very strong, obviously, because the parameters are going to be correlated with themselves. We also are going to look at the correlation between the various pairs. And so the outliers are the house type and the square footage. So the house type has a value that is very yellow, so it's a negative correlation, and this blue shade is going to be at about 0.04, the square footage of the house, and its correlation to the sale price. Notice, of course, that this graph is symmetrical about this midline here. I probably would have chosen to set up the graph so that the diagonal is going about y equals x, but it's really the same thing. It's just going in this direction instead. Okay, so we have taken a look at a couple of ways that we can do some graphing to get a sense of what is going on with our data. And so that's great. It kind of gives us some sense for what we might expect in the upcoming challenges that we look at as we are modeling our data. So I'm just going to minimize these down again so we can come back over to here so we can get a closer look at what we are doing. So now we're moving on to part 4, the regression model for the data prediction. So this is great. Now we are going to, in fact, actually try to do a prediction. So we have a couple of different ways that we can do that. We're going to consider today the linear regression model and also a decision tree regressing model, which will then allow you to sort your data into multiple categories. And we'll see if this is going to be any good at predicting our outcome. So we're going to need to get some of these methods from these scikit-learn. So if you've installed your TensorFlow, then you will have scikit-learn because that's a dependency of TensorFlow. This is the workhorse that contains much of the modules that are in fact needed to do the training and testing and so on. So here we go from sklearn.model selection. We're going to import the train test split. So this is going to be needed in order to take our data set and split it into testing and training sets. So here again, we're going to do this drop. So we are going to have X be everything except the sale price. And notice that we have, again, axis equals 1, which means we're going to select this as a column. That is the sale price as a column. So a typical notation is to have the capital X and the lowercase y. And this is probably because it's useful to think of most of your data set is being the X. This is the independent variable, the data that you're putting in, and y is the thing that's going to depend on that. That is the thing that we are trying to predict. So what we're doing in our data set is we're trying to select everything except the sale price, because the sale price is the thing that we want to predict. So this is how we do that. We do the df.drop in order to get the sale price, and x is equals 1 for the column selection as opposed to row. And then we are going to have the y values are going to be df, and we're slicing out the sale price column. So you see that overall we have now split our data set basically using the drop and the slicing of the original data set. Now we are going to do our X train and X test, Y train and Y test to get out our actual data sets. And now we're going to do train test split. And we are going to use the X and Y sets. The test size is going to be 0.5. So we need to specify how we're going to partition our data. This is saying 50-50, split the data set in half. And we're going to then randomly select which points go into which one so that we don't have any bias perhaps in some way that the data was entered into the spreadsheet. So these will be sorted with some random assignment into the two sets, and this is also going to be shuffled. So now we're going to use from sklearn the linear model. We're going to import the linear regression, which we need because that's the particular type of a model we're going to implement today. So we're going to initialize the linear regression model, so LR, which is our linear regressor, and we're going to do the linear regression of copy X equals true, and then we're going to do our fitting, so LR.fit, and we have our X train and Y train data. So this is going to be used to do the training. Now that we have implemented, so you see that in fact working with many of these tools, it does really black box quite a lot going on here. In this video, we're not going to focus on actually understanding the theory behind this, but that is something that is important to understand in order to really be good at doing your machine learning. All right, so we'll talk about this in another video. So here we can print about the linear regression model has been fit successfully. And here you see we have it printed out over here. And also we're going to now make the prediction. So y hat will be equal to the linear predictor using the X test set. And so this will tell us basically how we did. Well, it does the calculation to do that. So now what we need to do is we need to import the metrics. So we're going to see how well it's performed. So we're going to look at the mean squared error. We've imported this from sklearn.metrics. And we will report out the number for the mean square error. And then the next thing we can do is also look at the R-squared error called, which is the coefficient of determination, which is going to tell how close the data lies to the fitted regression line. So when you do a fitted regression line, basically what you're trying to do is draw a line through all of your data points. So we have all of those predictors, and the outcome is the housing price. So we're going to fit a line to that. And when we are running the R-squared statistic, we are looking to see how much difference there is between the predicted values and the actual values. Recall to mind that we have put in our data set so that the information is available to the model when we are testing our data to see what it is. This will tell what the confidence is, so that if we were to in fact apply this model to a data set for which we had the same inputs, that is information about the fireplaces and the square footage year built and so on, in order to determine what the overall price is. Finally, we're going to try the decision regressor. So this decision tree is going to allow you to categorize things into more than one category. So here we have our sale tree is going to be equal to the decision tree regressor. And we're going to allow some random states. We need a seed for this to be 100. You could set your seed as you wish, doesn't really matter. Now we're going to fit the regressor with the X and Y data, just like we've done above. So here we're going to have the X train and Y train data using the fit command so that we are in fact fitting our data. And then we would report out that it's been trained successfully. Now we're going to also follow up with some metrics on this, just as we have done with the first model. We can print the decision tree accuracy And so we can get the accuracy score from the metrics module, and this will give us some information about our model. All right, so when we take a look at this, we see that we can get out some information on our regressors. The R-squared data, I'm not actually sure what's a good value for this, and the accuracy measure. We also have information on how well it fits. The mean square regressor model tells us this, so it's a little bit ambiguous to me exactly what all of these mean. But this is basically working through the tutorial that has been laid out for us. And so in the subsequent videos, we are going to dig into this a little bit deeper so that we really understand what is going on here. This here, when we look at the R-squared error, this is telling us that about 38% of our data has been accounted for using the variables that we use. So it's not a super outstanding model, but it is a model which is set up and making the predictions. So coming out of this, then this does raise a couple of important questions about additional steps that we might want to do. We might want to, in fact, actually do other types of models. And so we haven't really covered how one might do additional model types. So there are many other models just besides regressors and additional regressor types. So one may wish to explore some other ones of those. So how could we do that? How could we find out what else is in the packages that we're working on? This is coupled to that question because we may wish to explore something else. So something we'll also cover in an upcoming video is how is it that you can go in and use the Python documentation system to learn more about the various models that are available and the things that are in the package. You can also learn how to read the source code, which will be very useful. So we will, in addition to that, learn how we can go out and look at the various pieces of the source code. One other thing that I was a little bit disappointed about in this particular tutorial setup is that there isn't a whole lot about looking at what the actual Y values were and what actually got predicted and how you would do an assessment on that. I think it's probably in some of these statistics that are running, but that is something else that I would like to follow up on so that we can get some more information on that and perhaps also design our own plots. All right, so I hope you have found this video to be helpful in getting started with the TensorFlow. And I also hope that you have found this to be helpful in terms of just getting up to speed using some working code, which is really the purpose of this little book. And here I've just sort of taken you through my own experience with doing that. So it is quite possible to do it. And I think the tutorial overall is really good because it does provide a good working example. Out of all of this, there was one command for the descriptions that didn't work for me, which I skipped over. But overall, I would say that everything generally works and is explained really well. And hopefully just looking through this script with me has been useful to you for just getting up and started and actually having a working model. The key next steps from here would obviously be making this into your own code. So asking your own questions and knowing how to go and answer those questions using the tools that are provided in the TensorFlow package, including the scikit-learn and the Seaborne for the plotting and so on. So those are some of the skills that we'll be hoping to develop as we explore working with other data sets and learning a little bit more about how to work with this package. All right, I hope this has been helpful to you, and we look forward to seeing you next time to explore some more of these ideas. Thanks so much, and we will see you later. Bye-bye.